Hey guys, today we are going to start section 9.3, and from 9.3 on, what we're going to be learning is different ways to solve quadratic functions. Okay, so depending on what form they're in, sometimes there's easier ways to do it. One way is easier than another way. Okay, the ways that we're going to learn is we're going to learn graphing, square root, factoring, completing the square, and quadratic functions. There's going to be 5 different options we have. And again, we're going to talk about why you would choose one other option over another just for the sake of efficiency. Okay, today we're going to look at probably the 2 easiest methods. The first one's graphing, second one's square root, but we can't use them all the time, and I'll talk about why we can't as well as we go through these. Okay, so remember, quadratic functions can come in 2 different forms. Okay, standard form and vertex form. Okay, now for graphing, we can do it either way. It does not matter. Okay, for the square root method that we're going to look at today, it actually would have to be in standard form, and we'll talk about what's unique about the b that we would use the square root form as well. Okay, really the only form we're going to use for the vertex form is graphing. Okay, all the other methods we will be working in standard form. Okay, one other thing you might see is you might see roots or x-intercepts. The calculator actually calls them zeros as well. Kind of all different names for the same thing. Okay, but those are going to be the solutions to our quadratic functions. So when we're graphing and looking for the solutions, we're looking for the x-intercept. Where does it cross my x-axis? Okay, wherever the graph crosses the x-axis, that will end up being our solutions. Okay, so that's what we're going to be looking at today as we go through the graphing method. And then as we do the square root method as well, we'll be looking for the intercepts or the roots. Okay, again, just kind of some different names they have for them. Okay, so example 1 says solve each equation by graphing the related function. If it has no real number solution, write no solution. We'll talk about that. That's one of our special cases. Okay, so you will need your calculators handy because really this is done on the calculator. There isn't a whole lot that we're going to do by hand for these. Okay, so the first one that you guys have is x squared minus 16 equals 0. You'll notice that you don't have a y here. The y has been replaced with a 0 because we're looking for the zeros. Okay, we're looking for the x-intercept. So that's why that has been replaced with a 0 when you solve. Okay, when you solve these, they're not going to have y's in them. Okay, if they have y's in them, then typically we're graphing or working with some other pieces with them. Okay, so you want to go into your calculator and you still want to put this in your y equals though. You're not going to put the 0 part in. Okay, you're just going to have it and it's just going to be y1 equals x squared minus 16. Just in your graphing calculator like we have all year. Then you want to go to your graph. Okay, and what you're looking for the graph is you're looking where does it cross my x-axis. Remember, this is the x, this is the y. So I'm looking for where does it cross. It can cross 2 times, 1 time, or not at all. And that's how we'll get our 3 different solution possibilities for solutions. Okay, so if you put this one in the calculator and you look at the graph, you're going to notice that it crosses at positive 4 and negative 4. You probably don't see the bottom of it because it dips too low. It actually dips down to negative 16. Okay, but it's going to end up kind of looking something like this. And then you guys just won't see the bottom of it down there. Okay, but all you care about and all you're looking for is where does it cross that x-axis. So in this case, this one would cross at 4 and negative 4. So those would be our 2 answers. Okay, that's what you're looking for when we're graphing it. Okay, so again, that's all you really have to do for these. Okay, put them in the calculator, see where it crosses the x-axis, and then that will be our solution. Okay, second one you guys have is 2x squared minus 8 equals 0. So same idea, go ahead and plug it in the y equals in the calculator, okay, and graph it, and we'll see where it crosses. Okay, on this one you should see that it crosses at positive 2 and negative 2. Okay, this one you can also see the bottom of it, it's down at negative 8. So it kind of goes like that. Okay. So that means that x would equal 2 and negative 2 because that's where it is crossing the x-axis at. So those ones were both in standard form. Let's go ahead and look at ones now that are in vertex form. Okay, so for C, you have x minus 3 squared equals 0. Okay, again, make sure you have the parentheses. If you don't have the parentheses, then you're going to end up getting the incorrect answer. Now, what you'll notice is unique about this one is it actually goes down to the 3, touches, and then goes back up again. Okay, that's fine. That touching still counts as an answer. This one doesn't have 2 answers. It just has 1. Okay, so our only answer would just be x equals 3 because it only touches in 1 spot, not 2 spots, and that's fine. That's going to happen sometimes. Okay, a lot of times we'll get 2 answers, but we don't have to. Okay, we can end up with 1 answer, or as we're going to see on the next one, you can end up with no answers. Okay, so if you graph the last one I have for you guys then, okay, when you graph this one, you're going to notice that it doesn't even touch. Okay, the vertex ends up being right here, and it goes up from there. Okay, this one never touches the x-axis. If it doesn't touch the x-axis, then we say that it has no real solutions. It has what's called imaginary solutions, which you guys will get into in Algebra 2, but it does not have any real number solutions that we can find because it doesn't cross the x-axis. All right? So it'd be really nice if we could use this method all the time, but we can't. Okay, because we can only use this method if it's going to end up being really nice answers. But in the reality, most of the time when you have quadratics, you're going to get decimal answers. Okay, and we can't pick out decimal answers by graphing. Okay, so that's why we have to have some of the other methods that we're going to end up looking at over the next couple weeks. Okay, so the next method, again, that was the graphing method, and you're only going to graph if they tell you to graph, because otherwise the numbers probably don't work out very nicely for us. Okay, the next type we're going to deal with is the square root method. Okay, now this method comes in really handy, okay, whenever you don't have a B term. Okay, if you have a B term, you cannot use this method. And what I mean by a B term is if you look back at your quadratics, you have this bx here. Okay, if you have a number with the x, then you cannot use the square root method. It just does not work. Okay, so if this term is missing and you just have these 2 terms, that's when we can use the square root method. Okay, and it's a really fairly quick method and it's really handy. Okay, but again, it only works if you don't have that term. If you have that term, we can't do it, and we'll look at one of the methods that we're going to use over the next couple days. So example 2 says solve by finding the square root. Again, if it has no real number solution, then we'll write no solution. Okay, so the first one you guys have is n squared equals 81. Okay, so you'll notice this would be like your ax squared because it's a square term. This would be like your c because it's a number. And again, remember how I told you, technically this doesn't exist anymore. It gets replaced with a 0, okay, whenever we're doing solving. Okay, so the whole goal of the square root method is to get the variable by itself, which it is here. And once you do, the opposite of squaring something is to take its square root. Okay, so that means once I take the square root, I get 9. And we're also going to get negative 9. Okay, and that's something you need to take into account because if I square 9, I end up with 81. But if I square negative 9, I'll also end up with 81. So it will always be the square root and its opposite. Okay, just like on the graphing ones, we had 2 answers for a couple of them. Okay, same idea here as well. Okay, we will have 2 answers most of the time unless it's one of your special cases. Okay, so square root method really is just taking the square root after you've gotten the variable by itself. Okay, if the variable isn't by itself, then we can't take the square root yet. Okay, so next one I've got is b. b is 5x squared minus 35 equals 0. Okay, so you'll notice this is like your A, this is your C. Okay, I have to get the variable by itself before I take the square root. Okay, so just your normal solving stuff. You would add the 35 to the other side. And then you would divide by 5. Okay, now that I have the variable by itself, now I can go ahead and take the square root. Now this one does not work out nicely. Square root of 7 is not perfect. You really have two options for this. Number one, you can either do a plus or minus square root of 7. Remember, that gives us both the positive and negative. We used that term earlier in the year. If you don't like that, you can write it out as square root of 7 and negative square root of 7. I don't care. Or you can put it in the calculator and round it as well. Okay, I think the book tells you to round to hundredths. I'm fine with that. I will actually accept either answer. Okay, either the rounded answer, or if you want to leave it, if it's not perfect, I am okay with that. You do have to make sure you simplify them though. Okay, we simplified radicals back in chapter 7, so you will want to make sure it's in its simplest form. Next one. Again, want to get the x squared by itself, so I would add 8 to the other side. We'll divide by 4. And then once we get to this step, last thing is to take the square root. Again, 2 does not work out nicely for us. Okay, so you can do plus or minus square root of 2. Write it out the other way, or you could round it. I believe this one's 1.41 or something like that. I'm fine with that too. It's kind of up to you. Next year you'll have to leave them as square roots, but this year you kind of have the option between rounding or leaving them as square roots. All right, so last one we got here. Again, want to get the x squared by itself, so I would subtract the 4. Now you're going to notice something. When I go to take the square root, if you would put that square root in your calculator, it's going to tell you error. Okay, anytime you take the square root of a negative number, it's imaginary. Okay, and if it's imaginary, then that means that we actually have no real solutions. Okay, so once you take the square root, if it's a negative number on there, you will have no real solution. Don't do that too soon though. Just because there's a negative in the problem doesn't mean that. It must be when you're taking the square root. Okay, but that can happen, and that's fine. That would just be like the graph that never touched the x-axis. Okay, they're both along the same line when we're working with those. All right, one last problem, kind of a little bit of a word problem here. It says the length of a rectangular prism is 2 times the width. The height of the prism is 5 inches. The volume of the prism is 80 inches cubed. What's the width of the prism to the nearest tenth? So this one does ask you to round. Okay, so for this one we have volume is equal to length times width times height. Okay, it tells us the volume is 80. It says length is 2 times the width. So I'm going to leave that as 2x and my width as x. Tells us our height is 5. Okay, so we're just going to go about this and solve just like we have with the other square roots. Okay, 2 times 5 would be 10, and I'd have x squared. Just look like the problems. Divide by 10 and you'll get 8. At that point we want to take the square root. This one did tell you to round, and if you round the square root of 8, you will end up with approximately 2.8 inches. Okay, so same type of problem, just kind of more in a word problem format, so you'd have to, set up your own equation, but kind of the same idea for us. All right? So again, graphing method we're only going to do when they tell us to. Okay, square root method we'll do whenever we don't have that b term. Okay, because it is the quickest one. And then we'll learn the next couple methods next couple days. All right.